Thank you for joining us for this fifth installment of 5-minute practice. This one is about the synthesis of this compound right here. And of course, when we're asking for the synthesis, we're not asking for the mechanism. I don't want you to be confused about that. First thing that stands out about this molecule is that in the study material, there is definitely an electron donating group, a methoxy group, which would be an OP director, and yet, well, by the way, it says 2 points, but there's no points associated with this. Yet in the product, there's nothing at the para position, which indicates that we probably have to protect that position, right? So, and then we see at the positions that are ortho to the methoxy group, we have amine and a bromine. The amine group could be, right here, could be synthesized from the corresponding nitro group, and the bromine, of course, can be installed by the halogenation reaction. So the rough idea is going to be that we're going to protect this carbon first, and then we go on from there. Okay, so first thing, the only sort of protective functional group that you could install on a benzene ring that we've learned about would be the sulfonic acid. So we do sulfonation using fuming sulfuric acid. That's the sulfur trioxide in sulfuric acid, which will preferentially happen at the para position, so right here. Now, if we were to treat this with a nitration condition, I want you to notice how the methoxy group is OP director, so you would direct to these two positions, and the sulfonic acid is an electron withdrawing group that directs to meta. So those two directors are kind of in agreement with one another, so we're going to see that the nitro group would be at one of the ortho positions. And of course, I could have drawn the nitro group right here as well. If you flip it over, it's the same thing. Okay. So with that on there, if we were to do, at this point, it's a better idea. There's two choices. We could either reduce the nitro group at this point so that we have this. The only problem with that approach is now the amine is also an OP director, so there's going to be a split sort of directing effects. Amine would like to direct it to these two positions, whereas the methoxy group would like to direct it right here. So there would be a sort of a split directing phenomena, and there's going to be a mixture of molecules, which would not be ideal. So for that reason, it's better to keep this a nitro group and then go ahead and do the bromination reaction at this point. That would be directed to this position specifically because the methoxy group is OP director, and both nitro and sulfonic acid is a meta director, which would direct the electrophilic aromatic substitution to that one carbon. So that would be very regio specific. And so now all that's left is we just have to reduce the nitro group to amine, which we can accomplish that doing it with stuff like that, or zinc also works. And in the second step, we need to sort of deprotect the sulfonic acid, which, remember, can be accomplished with copious amounts of water and sulfuric acid. So that would complete the synthesis there.